All right, friends, so what we have here is going to be, note that my last video was saved, these couple different terms. Now, these right here are based on the concept of a line from the front side, okay? So that's important to note that a segment and array is based on the concept of a line. All a segment is, or line segment, is part of the line between the 2 points and consists of all points between them. Notice the order of the letters does not matter in terms of those points. So a capital letter A, capital letter B, or B and A. No arrows on the ends there. The end point, now this is really weird, so I'm going to underline this in red. The end point is a point at one end of the segment or the starting point of the array. That is hashtag awkward and somewhat counterintuitive, but that is the definition. So it's important you understand that the end point is actually the starting point of the array. Now, if you look here, in this case, that's a segment, so that's not really highlighting that point in red. So we need to look below at this array. So if you look at the array that they've drawn, see the red? See how it's color-coded on this lovely sheet that we have here, okay? What you can see very clearly is that endpoint R is really where the array starts from. The array can go from left to right or right to left, just like we can read from left to right in English, but in other languages they do technically read from right to left. Array, I always like to think of the band One Direction. Baby, you're perfect. Okay, that's the last I'll sing. Because it extends forever in just one singular direction. The order matters. The order of the letters matters. Order matters. Okay? Finally, opposite rays, if you look at this picture, I mean, it's really similar to a line, but it has this common endpoint in between there, okay? So keep in mind that opposite rays have a common endpoint and they actually do form a line. What I would encourage you to do is pause and try example 2 and see if you can get something similar to what I have. If you can, great. If you can't, that's okay too. But I would pause the video and try example 2 right now. That's what we did in class, okay? I'm just going to go ahead and do it, but again, feel free to pause and try. It does say to draw, so you really should be using a device that has like a ruler or something in it, but for the sake of time and sanity, hashtag pandemic, we're not going to worry about that. So a segment with endpoints M and N. Got to have distinct points there, M and N. That's an example. I could have flipped those. I could have had that in a vertical orientation, and it would still be equally as correct. Opposite rays with a common endpoint T. T is common in between them. Opposite rays, you have one going to the right, another going to the left. What I will put here is an E. Whoops, that's a terrible E. Holla. T and then A. Estimated time of arrival. I want to get away right now, just saying. That would be an example with the common endpoint. What I noticed in my earlier classes, I had a couple friends do this, and they were close. I saw what they were going for. But unfortunately, that is incorrect because they need to have that already in common as you see in that picture up there. Then finally, letter C, array with endpoint M and containing N. You could have this going in either direction, but the direction does matter. The endpoint is the starting point, so M and then N. And that's it. All right, so that was a couple more vocabulary words. I know I stopped counting. I forget my count from the previous page. Let me look real quick. 5, 6, 7. I got up to 7. So this is 8, 9, 10, 11. Holy, we're going crazy here. And then 12. So you have 12 terms that you need to get familiar with, friends. That's a lot going on. But here's the thing. You're going to have time to process. So a postulate is a statement that's accepted to be true without proof. We will get to theorems that will require proof, okay? But these are accepted without proof. So a lot of these, they're going to be like common sense. And here's the reason why, because this is the geometry that most of the world operates and recognizes. There is another geometry called non-Euclidean where none of this is true. So that's why it's important for us to establish it here at the beginning. So firstly, the first postulate, through any 2 points, there's exactly one line. So if you put any 2 points anywhere, there's only one line that can be drawn through it. Duh. That's what I mean by common sense. It just feels right. It makes sense. The next one, through any 3 non-collinear points, there is exactly one plane containing them. Go ahead, put 3 points anywhere. There's a plane containing them. Fun fact, we should have desks with 3 legs. They would be way more stable than the ones that we have with 4, based on that postulate right there. Then if 2 points lie in a plane, then the line containing those points also must be in the plane. Like if there's 2 points and then there's a line, they got to be in the plane. I'm just saying. Finally, if 2 lines intersect and they intersect at exactly 1 point, you'll see that below. And if 2 planes intersect, they intersect at exactly 1 line. Okay? This is kind of like the little ornament boxes, if any of you have those at home, that keep the ornaments real nice and organized. We got that's like a little dash. There's a little plane there, like there. So really, right here is that 1 line that is intersecting, and that's what that's claiming. So for example 3, sketch, and sketch is very, hey, you just do your thing, kind of freehanding, all right? 2 lines intersect exactly 1 point. Somebody in my earlier class mentioned the idea of a T as I throw my pen down, sorry. That could work, but really I think the idea of an X-looking figure would be better. And then you could have that point in the middle. If you wanted to have additional points on there, you certainly could for the naming of it, but it's not necessarily. I'll just go with that as an example of letter A. Letter B, show a line that lies in a plane. Well, here's a plane, often looks like a parallelogram. Here's my, whoopsies, that's awkward, don't want it to stop. Line, it's important you have arrows on the ends. And then I'll just go with my initials, MF here, okay? Keep it clean, people, Mr. Funfarm. All right, those would be examples. So what you need to do now is make sure you take notes, submit these notes to Canvas. We'll clarify any of these things tomorrow if you're confused. You'll then get some practice, and there's a homework check. Now, you don't have to do the homework check today. You can do that tomorrow. I did put it on there because some people like to see right away, did I get the lesson? So that's something that you could do today if you wanted, or wait until tomorrow. Any questions, feel free to email me, but make sure you take those notes, submit it. I'd like 1 each, just actually this section. So you could submit 1 page at a time, so you would submit to that location twice. Give it a shot. Try not to submit the whole packet. And again, you got this, friends. We're doing a great job, and I'm proud of you. Bye now.